All right, so welcome everyone. And today's class mainly talked about NoSQL. And we are in 11th week, pretty much one third left of our total course. So we'll also need to talk about the project grouping in this class. After my lecture, we'll spend some time on doing grouping, or at least initiate some discussion about group creation. So ideal size is 3. Now we have 29 students, so it will be 29. So probably one group will be 2 and 28 group will, so 9 group will be 3 people. Okay, so you can think about creation your group. So NoSQL and big data. And again, if you talk about big data, we are not in a course that deal with big data analysis or whatever. So we'll just introduce big data to you to introduce NoSQL, because if we like to introduce NoSQL and don't talk about big data, it doesn't make sense to why we are dealing with NoSQL. So let's read this slide, the motivation of NoSQL.
Very large volumes of data being collected. Driven by growth of web, social media, and more recently Internet of Things. Weblogs were an early source of data. Analytics on weblogs has great value for advertisements, website structuring, what posts to show to a user, etc. Big data, differentiated from data handled by earlier generation databases. Volume, much larger amounts of data stored. Velocity, much higher rates of insertions. Variety, many types of data, beyond relational data.
So this slide is very important, like a lot of information here. And you can see the internet is kind of our daily life now. So, and growth of web and social media and Internet of Things, that means the devices always connected with internet and transmit and receive data. So those devices are called Internet of Things, like weather, different alert system. There are tons of Internet of Things, even smart home devices like your smart bulb or whatever, your car that connect to the internet, all of those Internet of Things. And as those devices are connected, they exchange data, and we need to keep a place to store those data. And as the data are continuous, 24 hours data is generating, transmitting, receiving. It's a huge process. So the first generation databases like MySQL, Oracle, DBase, those data management systems are very robust, but not fit to handle very large volume of data. And large volume is, say, if we think about banking data, is still large. But if you think about social media data, then banking data is still small. So when you're thinking about big data, we are thinking about data really very big, like terabyte, petabyte, this kind of scale. And we characterize those data with 3 different characteristics. So first, volume, velocity, and variety. So much larger amount of data is stored, that volume, much higher rates of insertion. Insertion means keeping in the database, or retrieving from database, that also include the velocity, and variety of data. So videos, text, log files, images, and images has different types, different resolution, size. So massive amount of data. So when you see those three characteristics of data came, the conventional database system unable to handle efficiently. In that case, we need a different type of database management system, and that we are calling NoSQL. So let's move forward to the next slide. And now querying big data.
Transaction processing systems that need very high scalability. Many applications willing to sacrifice ACID properties and other database features, if they can get very high scalability. Query processing systems that need very high scalability, and need to support non-relation data. ACID, review transaction. Atomicity. Consistency. Isolation. Durability.
So can you remember when you discuss transaction, we know about ACID property of MySQL. Now, and this is very important for different type of transaction, especially banking data, right? So say social network data is little different than the banking data. So if we have an operating system and we like to do a sacrifice on ACID property of this database, then it will be easier for us to tackle all those data, because those social network data means all those social networking data or Internet of Things data may not be as sensitive as banking data. So when you sacrifice this ACID property for other operating system, we can create a new category of a database system that called NoSQL. So let's move forward to next slide. This slide talked about the different database systems, and this classification based on the database level. How do we store that huge amount of data? So don't mix up with NoSQL or SQL. Those file database systems are talking about a database level. Maybe some are NoSQL, some are SQL. So let's know about those four different types of database management or big data storage systems.
Distributed file systems. Sharding across multiple databases. Key value storage systems. Parallel and distributed databases. Note, this classification is in the DBMS level.
Right. So let's know about distributed file system. What is this distributed file system?
A distributed file system stores data across a large collection of machines, but provides single file system view. Highly scalable distributed file system for large data-intensive applications. E.g., 10K nodes, 100 million files, 10 PB, petabyte. Provides redundant storage of massive amounts of data on cheap and unreliable computers. Files are replicated to handle hardware failure. Detect failures and recovers from them. Examples: Google File System, GFS. Hadoop File System, HDFS.
Okay, so in distributed file system, you can see, you can consider this 10K or 10,000 nodes means 10,000 connected computers for data sharing or whatever. So this is an example, but if you go in social network, the nodes are even higher. And that's why Facebook has multiple stations. Say they have USA, they have in Asia, like different server to control all those nodes, because one server cannot tackle that amount of data. So, and different region has their different server, and they tackle those nodes from different distributed locations. And those file systems can store those data. And one of them is distributed file system, but as you see, they are not that reliable, right? So for those systems, you don't need to do any coding, just you are taking concept of different distributed file system or storage of big data storage systems. So one of them is distributed file systems. And say, if it is a class of big data, then probably we'll talk about Hadoop or Hadoop, whatever your region or pronunciation. So Hadoop. But because it is a database management class, so we'll be switching to NoSQL after knowing those. Now, sharding. This is another type of storage system to tackle big data.
Sharding, partition data across multiple databases. Partitioning usually done on some partitioning attributes, also known as partitioning keys or shard keys, e.g. user ID. E.g., records with key values from 1 to 100,000 on database 1. Records with key values from 100,000 and 1 to 200,000 on database 2, etc. Application must track which records are on which database and send queries/updates to that database. Positives: scales well, easy to implement.
Now, say out of those 4 different kind of big data storage management system, some of them may not be used forever. They are just kind of proposed and tested, and they never go in a operational form. Like here you can see Google file system or Hadoop, but we don't see sharding. I never heard anything. So these are probably in a proposal level. Someone tested and it didn't actually working in the market. But we are knowing it because we need to know it. The drawbacks.
Drawbacks. Not transparent. Application has to deal with routing of queries that span multiple databases. When a database is overloaded, moving part of its load out is not easy. Chance of failure more with more databases. Need to keep replicas to ensure availability, which is more work for application.
So, like tackling those data, or if the process is not even transparent, why people use this kind of thing? So it is not in the market. Parallel database and data store. That's one of the things people used for time to time. But again, it's not in highly available in the market. So it's parallel databases and data stores.
Supporting scalable data access. Approach 1, MEMC or other caching mechanisms at application servers, to reduce database access. Limited in scalability. Approach 2, partition, shard, data across multiple separate database servers. Approach 3, use existing parallel databases. Historically, parallel databases that can scale to large number of machines were designed for decision support, not OLTP, online transaction processing. Approach 4, massively parallel key value data store. Partitioning, high availability, etc. completely transparent to application. Sharding systems and key value stores don't support many relational features, such as joins, integrity constraints, etc., across partitions.
So in these parallel databases and data store system, you can see there are 4 different approaches. And every approach has their own advantage and disadvantages. So again, this may not be available in the market for use and handling big data. So key value system. This is another interesting types for handling big data.
Key value storage systems store large numbers, billions or even more, of small, KBMB, sized records. Records are partitioned across multiple machines and queries are routed by the system to appropriate machine. Records are also replicated across multiple machines, to ensure availability even if a machine fails. Key value stores ensure that updates are applied to all replicas, to ensure that their values are consistent.
Right. So you can see this is not even practical. If you replicate everything in all machines for availability, that's an extra work. So this is also a proposal and may not be practical in the life. Let's know little more about those, but one of them is document stores. So we need to know this one. And key value storage system has some relation with NoSQL data. So if you read this slide, we'll get some idea. So key values. So uninterpreted bytes with an associated key. So you can see this example, Amazon S3, Amazon Dynamo, white table. This is another approach. And JSON, JavaScript object notation file. And you can see this is the relation between key value storage system and Mongo. And Mongo is a NoSQL data database management. And you can see Amazon S3 and Amazon Dynamo. These are those examples. Again, here, white table approach. So there are three different approaches here: uninterpreted bytes, white table, and JSON, JavaScript object notation database system or document model. So those are those examples here. And white table, Google Big Table, Apache Cassandra. Apache Cassandra got some attention, but I'm not sure if it is still in use. But you can see Mongo is taking place very rapidly. And Amazon certainly upgrading their big data management system. Like all those big companies are fighting to implement those, their own version of big data management and cloud storage system. And Amazon, Google, Facebook all have their own role, and Mongo also has widely accepted in that race. Now, document stores.
Document stores store semi-structured data, typically JSON. Some key value stores support multiple versions of data, with timestamp/version numbers.
Right. And you can see this key value storage system had some connection with NoSQL database management. And this slide is showing how this JSON format works to represent some data in a NoSQL dataset. So this is just an example. And because you already started using Mongo, you are quite familiar with this at least. Now let's take more information on key value storage systems.
Key value stores support put, key, value used to store values with an associated key. Get, key which retrieves the stored value associated with the specified key. Delete, key, remove the key and its associated value. Some systems also support range queries on key values. Document stores also support queries on non-key attributes. See book for MongoDB queries. Key value stores are not full database systems. Have no /limited support for transactional updates. Applications must manage query processing on their own. Not supporting above features makes it easier to build scalable data storage systems, also called NoSQL systems.
Okay, so now we can see we talked about 4 different big data management system, and one of them is key value storage system. And from this key value storage system, we are getting some idea about NoSQL data management system. And those put, get, and delete, same as read data Put means write data, get means read data, and delete means delete or remove data, right? So you can see those basic operations in this key value storage system. But the limitation is have no or limited support for transactional update. So that's we talked about very starting that why ACID property is important, and this is one of the reason we are still learning SQL. Okay. In the next slide, NoSQL is schema-less. So if we go is relational model, we can see the relations, tables, and different attributes inside the table, means the rows, right? And they have their key so that we can identify themselves. But in the document, you can see this one ID, and that ID has different values, right? And that's why it's called the schema-less database management system, and that's NoSQL.
In NoSQL databases, there is no schema to consider. There is no unused cell. There is no data type, implicit. Most of considerations are done in application layer. We gather all items in an aggregate document.
Right. You can see those are as a form of document. And another thing is there is no data type. That's interesting. But when you learn SQL, it is very easy to mention the type of the data. So as soon as you create a column, you have to create a default data type, or the management system will choose a default data type. So data type is very important in SQL, but not important at all in NoSQL. And they gather as a relation in SQL, but they gathered as a document model or as document in NoSQL. Now let's introduce NoSQL formally. What is NoSQL?
NoSQL stands for not only SQL. NoSQL is an umbrella term for all databases and data stores that don't follow the RDBMS principles. A class of products. A collection of several, related, concepts about data storage and manipulation. Often related to large data sets.
Right, so it's not only SQL. So it's more than SQL. That's it is trying to say. You might see some other interpretation about NoSQL, but not only SQL is the most acceptable terms to represent NoSQL. And NoSQL is an umbrella term. And under that NoSQL, you can see a lot of different kind of database management system like Firebase and Mongo got a lot of attention. Also, Cassandra got a lot of attention. Now there are lots of small databases. Probably I put a link so that you can find a big list of NoSQL data management system. Now in this slide, you can see in 1970s, when the use of personal computer started and data started to grow in that time, and as soon as the internet came and the machines are get connected globally, that data exploded. And you can see in 1970s called CORDS relational model, IBM System R, then Oracle came, and Oracle lasted for around 10 years. Then the new database DB2, Sybase IQ, ITB, and Oracle has several versions actually. Then finally, these 2010s, the idea of NoSQL came, because in that time, the explosion of data took place in social network. So YouTube came, different social media platform like Facebook, but before Facebook, there are some other social network. If you just Google it, you will find the timeline for different social media networks in that time. And Facebook actually bought many of them. So, and they merge and they become grow globally, and they have tons of data. And in 2010, so not exactly 2010, like 2010s, in that time, the NoSQL started. I saw this video. This is really great to introduce NoSQL. So let's listen this video.
Not just data storage, not only SQL data storage. Not just data storage, not only SQL data storage. NoSQL, short for not only SQL, is an approach to database design for a variety of data formats and is especially useful for large sets of distributed data. NoSQL is an alternative to traditional relational databases that store data in tables and use structured query language, or SQL, to query and gather data. There's also NewSQL, an emerging class of database offerings that intend to bridge the gap between SQL and NoSQL. Read more about NewSQL in the link above or in the description below. NoSQL systems aren't required to follow an established relational schema or structure, unlike relational databases, making NoSQL systems suitable for organizations that want to focus on narrow operational goals and produce high-grade data consistency. In large-scale database clustering, NoSQL databases are preferable to relational database management systems. The need for NoSQL's performance and scalability outweighs the need for relational databases' immediate rigid data consistency. NoSQL is more like a description of a database rather than a specific kind. There are 4 primary categories of NoSQL databases that avoid rigid schemas. Document databases store data elements in document-like structures, usually for content management and monitoring apps. Graph databases emphasize connections between data elements, suitable for recommendation engines and geospatial apps. Key-value databases use a data model that pairs a unique key and its value in storing data elements, good for storing clickstream data. And wide column data stores, or table-style databases that can have large numbers of columns, good for large-scale web apps and internet searches. What kind of NoSQL databases do you use? What for? Let us know in the comments and hit that like button.
So I found this video is very interesting and a quick, good introduction to NoSQL. And as you saw in the video, there are 4 different type of presentation or category of NoSQL data. Now, key value is still we got when we differentiate the database management system for big data. Key value is one of them. So here also getting some idea about key valued NoSQL. Now, document presentation, column family, and graph. And you can see some example here. In document kind, you can see Mongo. In column family, you can see Cassandra. And this Cassandra actually started by Facebook. And I do not see the name here, Firebase. Firebase also a document kind. Now, this is graph kind and key valued kind. But from now, our concentration will be on document presentation of big data. That's we will be dealing with Mongo, and you will learn at some point Firebase 2 in other course. Okay. Family of databases. As I said in the previous slide that will be talking about the document databases from now. So all other three kind, that's, I guess you already have some idea about key value, but you can read those other kind, and you can click in the link below to have more information from that link. Okay. So in document type databases, and that's obviously NoSQL, stores data elements in document-like structure, and we know that's JSON, right? Common uses include content management and monitoring web and mobile applications. Couchbase server, CouchDB, MarkLogic, and MongoDB. So you can see some names. Those are even we never tried or never heard. And what those companies, I don't know. So, but we'll be interested in MongoDB. So three other kinds, please read yourself and know about them. Okay. Now, this slide is mentioning you the difference between SQL and NoSQL. So the purpose, NoSQL is specific use cases and SQL is general purpose. So probably in this world still there are many databases existing that use SQL, whatever MySQL or Oracle, but that's use SQL. And for say business, medical applications, everything use SQL, banking. So that's why we need to know SQL as well. SQL not required. There is no API. SQL API is not required, and SQL required an API. Data models various depending on NoSQL database types, whether it is key value or graph type or document model. That's is talking. But all SQL data variations or SQL databases follow the same thing, tables with fixed rows and column. Whatever you are using, Oracle or MySQL or only SQL. Schema flexible, and it is rigid because it follows ACID property. Scalability is horizontal and very high scale. It's vertically scale, but it's not that scalable compared to NoSQL. Now, data integrity, it follows Bayes. The Bayes model provides high availability. So remember, high availability. But ACID model provides a consistent system. So like transactions. So consistency is very important for SQL. Okay, performance. Let's read this slide.
There is no perfect NoSQL database. Every database has its advantages and disadvantages. Depending on the type of tasks and preferences to accomplish. NoSQL is a set of concepts, ideas, technologies, and software dealing with big data, sparse semi-structured data, high horizontal scalability, massive parallel processing. Different applications, goals, targets, approaches need different NoSQL solutions.
Okay, so as you said, there is no perfect database, no SQL database. So, but we'll be learning the most used databases in present time, and that will be Mongo and Firebase for your courses. And you will know Firebase in mobile development, and you will know Mongo in your full stack courses. But here we will be presenting Mongo as a database. Now, where do I use it?
Where would I use a NoSQL database? Do you have somewhere a large set of uncontrolled, unstructured data that you are trying to fit into a RDBMS? Log analysis. Social networking feeds, many firms hooked in through Facebook or Twitter. External feeds from partners. Data that is not easily analyzed in a RDBMS, such as time-based data, weekly weather data, temperature readings, health monitoring, stock exchange, etc. Large data feeds that need to be massaged before entry into an RDBMS.
Right. So you can see those examples are all examples of big data. And in case of big data, you will be using NoSQL, not the SQL. So that's it is telling us. And as I mentioned you, we'll know Mongo and Firebase. And in this course, we'll try to learn Mongo as a database. So Mongo, what is Mongo?
MongoDB. A document database, also known as a document-oriented database or a document store, is a database that stores information in documents.
Right. So that Mongo. Now, in SQL or MySQL, you learn all those DDL and DML. Can you remember DML? So data manipulation. And in data manipulation, you actually read, modify, delete, or remove, right? Or update. Those operations is DML. Same as in NoSQL is called CRUD operations. And those are important for NoSQL.
Document databases typically have an API or query language that allows developers to execute the CRUD, create, read, update, and delete operations. Create documents can be created in the database. Each document has a unique identifier. Read documents can be read from the database. The API or query language allows developers to query for documents using their unique identifiers or field values. Indexes can be added to the database in order to increase read performance. Update existing documents can be updated either in whole or in part. Delete documents can be deleted from the database.
Okay. So it needs, so CRUD, C-R-U-D, is pretty much same as DML for SQL. Now, a few questions that frequently asked in related to Mongo.
Is MongoDB a document database? Yes, MongoDB is a general-purpose document database. What is an example of a document database? MongoDB is the world's most popular document database. Other examples of document databases include CouchDB and Firebase. Which field is always the first field in a document? In MongoDB, the first field in every document is named _ID. The _ID field serves as a unique identifier for the document. See the official MongoDB documentation for more information. Note that each document database management system has its own field requirements. How is MongoDB data stored? MongoDB stores data in BSON, binary JSON, documents.
So it's saved as BSON, means binary JSON. So it's actually JSON file. And if we go in this link, this is very important and very interesting, I found while preparing my lecture. Most popular document databases. And this list is really big. And you can see Mongo and the first, Amazon Dynamo, Azure, and I can see Firebase here. Then Couch, I never use Couch. And you can see on Go. So I can see there are how many? Starting from 1, 40, 45. Then why this 46 is repeating? So you can say probably the different version of something, I believe. is open source. It started in 2014. Now we can see such a big list of NoSQL database, but we only use few, or the few of them is popular. Let's know about Mongo. So Mongo initial release in 2009, and the company is MongoDB Incorporated. It's an open source, so it's using C++ and supported programming type. So a lot of platform is supporting Mongo, actually, you can see. Even PHP, that's interesting. Okay. Server-side script is JavaScript, and that you will be using most places, either JavaScript or TypeScript for different thing. Multi-document ACID transactions with snapshot isolation. So we need to know this. Support to ensure data integrity after non-atomic manipulations of data. So it supports some sort of ACID transactions. So that's interesting. Okay. So let's go back. So you can see, if you have time, I will ask you to explore these and look at these few of them, not all, probably first 10. Maybe if you have any question in your interview, so that you will find more confidence while talking on NoSQL. Now, a couple of more questions here.
Is MongoDB free to use? Yes, MongoDB has two free options. MongoDB Atlas, MongoDB's database as a service, has a generous, forever free option that is great for kicking the tires and learning to use MongoDB. If you prefer to self-host MongoDB, you can use MongoDB Community Server in accordance with the server-side public license, SSPL.
Okay, so I believe Mongo Atlas is good enough for you, and I believe you are using Mongo Atlas for your full stack course.
Yes, Prof.
Yeah, okay, good. Now I added two links here. That's actually a quick tutorial, right? And you will find a video that came from the Mongo official page. And this video actually showing how to create this Mongo thing. It's a few minutes long video, probably 3 or 4 minutes. 4 minutes.
Hey everybody, I'm Maxime Bonnier, developer advocate here at
So at this point, I am